Welcome, fellow builders. If you've ever had a great idea for a gadget or tool, you've probably wondered, plastic or metal? It's a crucial choice that shapes your entire design. Choosing the right material isn't just about looks. It affects strength, cost, and how your product works in the real world. Building with metal is like using Lego, strong and rigid. Plastic is more like modeling clay, flexible and creative. In this guide, we'll break down the 7 key differences between designing for plastics and metals. No jargon, just what you need to know. Ready to turn your idea into reality? Let's dive in. When it comes to choosing materials for any project, the biggest difference you'll notice is how they behave under pressure. The key factor? It's all about how these materials handle stress, strain, and repeated use over time. Metals, for example, are known for being stiff and incredibly strong. Think of the steel beams that hold up skyscrapers, or the solid aluminum wrenches found in every toolbox. These materials barely flex, even under heavy loads, making them perfect for parts that absolutely must hold their shape and support weight without bending or breaking. On the other hand, plastics are much more flexible. They can bend and twist, then spring right back to their original shape. That's why they're used for things like remote control casings or phone covers, items that need to survive drops, bumps, and everyday wear and tear. But metals have their downsides. They can rust or corrode when exposed to moisture or air, so they often need protective coatings or are made from special alloys to last longer. Plastics, in contrast, don't rust at all, making them ideal for wet or humid environments like bathrooms or outdoor furniture. However, they have their own weakness. Prolonged exposure to sunlight can make them brittle and prone to cracking. Another thing to consider is that plastics can slowly deform if they're under constant load, a process called creep. Over time, a plastic shelf might sag if it's holding too much weight. So, when you're designing something, ask yourself, does your part need to be rock solid and unyielding, or should it flex and absorb impacts to prevent breaking? For rigid, load-bearing parts, like a heavy-duty vise or the frame of a bridge, metal is usually the best choice. But for parts that need to flex, absorb shocks, or snap back into place, like a water bottle lid or a plastic clip, plastics are often the smarter option. Each material comes with its own unique set of strengths and weaknesses, and understanding these differences is crucial for making the right choice. By learning how metals and plastics behave, you'll be better equipped to select the perfect material for your next project, whether you need strength, flexibility, or a balance of both. Now, let's take a closer look at how these materials are actually made and what that means for their final properties. Once you've picked your material, it's time to shape it. The way you transform raw material into a finished part depends a lot on what you've chosen, metal or plastic. Each material has its own set of processes, advantages, and limitations. And understanding these is key to making the right manufacturing decisions. Metals are usually cut, milled, or machined from solid blocks. This subtractive process means you start with more material than you need and remove the excess to reveal the final shape. Precision is high, and tolerances can be extremely tight, making it ideal for parts that need to fit together perfectly. However, the shapes you can create are often simple. Think straight lines, flat surfaces, and blocky forms. Plastics, on the other hand, are typically injection molded. Here, melted plastic is injected into a custom-made mold, filling every nook and cranny. Once it cools, the part pops out fully formed. This process is incredibly fast and efficient, especially for making thousands or even millions of identical parts. It's perfect for high-volume production and allows for much more complex shapes than machining. But injection molding comes with its own set of design rules. You need to add draft angles, slight tapers on the sides of your part, so it can be released from the mold without sticking. Wall thickness should be kept even throughout the part to prevent warping or defects as the plastic cools. These rules are crucial for a successful mold and a high-quality finished product. Machining metal is more straightforward in some ways. There's no need for draft angles or concerns about wall thickness. But there's a catch. Every surface you want to create must be accessible to a cutting tool. This limits the complexity of the shapes you can achieve, especially for internal features or undercuts. That's why metal parts are often blocky and geometric, while plastics can be intricate, organic, and full of curves. The manufacturing process directly influences what's possible in your design. The manufacturing method you choose doesn't just affect cost and speed, it shapes your design options from the very beginning. Understanding these differences helps you make smarter choices and avoid costly mistakes. So, choose wisely to match your part's needs, whether you're aiming for strength, complexity, or high-volume production. The right process can make all the difference in performance and price. Next, let's talk about precision and how it impacts both your design and the final product. Tolerances define how much a part's size can vary from the design. Metals can be machined to extremely tight tolerances, perfect for high-precision fits like bearings. Plastics, molded by nature, have looser tolerances due to shrinkage and environmental factors. This means plastic parts have more wiggle room in their final size. For metal, you can rely on a snug interference fit. For plastic, you design features like snap fits to handle variation. Use the flexibility of plastic to your advantage. Snap fits hold parts together even if dimensions aren't perfect. The key design for the material's strengths and limitations. Now, let's assemble it all. How you join parts depends on your material. Metal parts use screws, bolts, rivets, or welding for strong, rigid connections. Plastics open up clever options: snap fits, ultrasonic welding, and adhesives. Snap fits are built into the part, no extra hardware needed. They're fast, cheap, and everywhere, like battery covers. Ultrasonic welding fuses plastic parts with high-frequency vibrations for a strong, permanent bond. Living hinges, thin, flexible plastic sections, let you create lids that flex millions of times, something metal can't do. Plastic assembly is about smart, integrated design. Metal is about strength and tradition. Next, let's make it look good. Surface finish matters, both for looks and feel. Metal parts get their finish after machining, sanding, polishing, painting, or anodizing. Plastics get their finish straight from the mold. Want a glossy or textured look? Just polish or etch the mold. Every plastic part comes out with a perfect, identical finish. No extra steps. You can still paint or print on plastics, but the real power is in designing the finish into the mold. For metal, finishing is a separate step. For plastic, it's built in. Now, let's talk money. Cost is a game changer. Plastics need expensive molds up front, sometimes tens of thousands of dollars, but each part is cheap to make, perfect for mass production. Metal machining has low setup costs and is great for prototypes or small batches, but each part stays expensive, even at higher volumes. If you need 1 million parts, plastic wins. If you need 10, metal is your friend. It's all about volume. High up front, low per piece for plastic. Low up front, high per piece for metal. Match your process to your production needs. Now let's talk design freedom. 9. Plastic lets you go wild. Complex organic shapes, multiple features in one part, and fewer assemblies. Think of a vacuum cleaner casing, curves, vents, handles, all in one molded piece. This reduces part count, assembly time, and potential failure points. Metal design, especially machining, favors simple, blocky shapes: blocks, cylinders, plates. Complex metal shapes are possible, but cost more and take longer. Let the material guide your creativity. Embrace complexity with plastic, simplicity with metal. Use plastic for integrated, multifunctional parts. Use metal for strength, precision, and clean lines. The right choice makes your design smarter and more efficient. Let's recap. Here's your ultimate cheat sheet for understanding the key differences between plastic and metal parts. Perfect for engineers, designers, or anyone curious about how things are made. Metals are known for their strength, stiffness, and precision. They're ideal when you need parts that can handle high loads, resist deformation, or require exact tolerances. Metals shine in small batch production, prototyping, or when durability is a top priority. Plastics, on the other hand, are flexible and can be molded into incredibly complex shapes. They're cost-effective for mass production, making them the go-to choice for high-volume products. Plastics also offer a world of creative design options, from color to texture to built-in flexibility. Metals are typically machined, which allows for tight tolerances and detailed features, while plastics are molded, enabling rapid production of intricate forms. Each process comes with its own unique set of design rules and limitations. Metal parts can be manufactured with very tight tolerances, making them perfect for applications where precision is critical. Plastic parts, however, have looser tolerances due to material flexibility and the molding process, so it's important to design with these differences in mind. When it comes to assembly, metals are usually joined with screws, bolts, or welding for a strong, permanent bond. Plastics often use clever snap fits, clips, or living hinges, which allow for quick, tool-free assembly and even moving parts built right into the design. Metal finishes, like painting, anodizing, or polishing, are typically added after machining. Plastics, however, get their finish straight from the mold, allowing for textures, patterns, and even logos to be built in during production. With plastics, you'll face a high upfront tooling cost, but the price per part drops dramatically as you scale up production. Metals have lower initial costs for small runs, but each part is more expensive to make, especially as quantities increase. So choose plastic when you need complex shapes, lightweight parts, or high-volume production. Opt for metal when strength, precision, and durability are your top concerns. The right material depends on your project's unique needs. Now you're ready. Take this knowledge and go build something amazing. Whether it's plastic, metal, or a combination of both, your next project is sure to be a success.